Hello and welcome to part 2 of this series on integers in Godot 4.x. This part is about using arithmetic operators with integers in GDScript. If you have not watched the first part on the what and why of integers in Godot, please feel free to watch that first. In this episode we will be covering all of the integer maths operations. So let's first have a look at what maths operators we have. All the basic ones are there for addition, subtraction, multiplication and division. We also have a couple of useful extra operators for modulo and exponentiation. All of these examples show literal integer values. In real code they would be variables or a mix of literals and variables. Modulo gives us the remainder from dividing the first integer by the second integer. In the Godot docs, this is actually referred to as the remainder operator in places. This operator is for integer maths only. There is a function to do this for floats, but although floats will be used in this tutorial for some things, there will be a separate tutorial to cover floats properly. Modulo is typically useful for doing things that require a cyclic sequence of numbers. For example, it is typical in role-playing games to have a day-night cycle that only lasts an hour or so in real time. You could have a game time counter and use division and modulo to calculate the in-game time from the counter. You can use modulo to obtain the current minute with total minutes mod 60. With a bit more division and modulo, we can also get the hours and days. This example presumes that day 1 starts at midnight. If you wanted to start at some other time in the day, simply add an offset to the total minutes value. By the way, we're using pure integer maths here, so fractional remainder values are dropped. For example, the total minutes value would have a fraction of 0.8 if we used floats. This is dropped to give us the integer value of 6,494. Modulo is also useful in shader language for things such as cyclic sequences that create repeating effects in a shader. However, this tutorial is just for GDScript, so there won't be any shader language examples. Exponentiation is where you raise one value to the power of another. In the example, we're cubing 3 to get 27, that is 3 times 3 times 3. In the Godot docs, this is also referred to as the power operator. There are more complicated things we can do with exponentiation when floats get involved, but again, that will be in the floats tutorial. As well as the operators themselves, an important aspect of using arithmetic is precedence. That is, if you have a chain of maths operations, which ones happen first? What we're looking at here is just the operators used for integer maths, plus grouping with brackets and the unary operators for negation and identity. Notice that spaces are significant in some cases. If a plus or minus sign has a space either side, it is addition or subtraction respectively. If a plus or minus sign is followed immediately by an integer variable or a literal value, it is identity or negation respectively. Identity, or unary plus, is not generally necessary but may help code readability in some cases. There are other operators in Godot that fit above, below and in between the maths operators in terms of precedence. We'll be looking at some of those in the last part of this series. While we're looking at precedence, it is worth noting that exponentiation works from left to right as shown in the example. If you want to change the order in which a chain of exponentiation is evaluated, either change the order of the operands or, more practically, put brackets around the part of the expression you want evaluated first. Depending on the values of the operands, this can affect the resulting total value. Before we dive into Godot, here is a handy tip for making big numbers more readable in your code. In any numeric value, we can insert the underscore character to break up the number and make it easier to read. This not only applies to decimal integers but also hexadecimal integers prefixed with 0x, binary integers prefixed with 0b, and floats. Here we are in Godot. This is the latest 4.1 release candidate of Godot, but everything we're going to look at is applicable to any 4.x version of Godot. This probably also applies to Godot 3.x, but I cannot vouch for that as I only dabbled with Godot 3.5 until the first alpha of Godot 4 became available. The first thing we're going to look at is something known as overflow. So, as you can see, we have a variable called big num that is statically typed as an integer, which is of course the int variable type in GDScript. If you have seen the first part of this series, you will know that each integer variable is stored as a 64-bit signed integer value. That gives a very large range, but let's see what happens when we're close to the edges of that range. Our variable big num is very close to the positive limit of the 64-bit signed integer. We're going to run this through a loop that increments the value and see what happens. Then we're going to do the same in reverse to see what happens there. As you can see, when we go beyond the highest possible value, we end up getting negative values because of how the integer value is stored. This is called an overflow because, a bit like a dam on a reservoir, we have flowed over the maximum capacity. The same happens in reverse if we are close to the maximum negative value and start subtracting from the value. If you look at the binary sequence, you can see that when we're adding each time in the loop, the binary value representation increments in a logical manner. However, because of the way that negative numbers are stored, when we have the 64th bit set to 1 and everything else is set to 0, this is our maximum negative number. If you recall from the first part of this series, the 64th bit indicates if a number is negative or positive. The 64th bit is now 1, so the number is negative. The final part of this series will give a proper explanation of how the negative values work, but for now the key point is that when the maximum positive or negative value overflows, it happens in a smoothly logical manner that makes sense in binary. That is, at the maximum positive value, all of the bits are set to 1 except the 64th bit. When we add 1, this ripples through the bits until the 64th bit is set to 1. And the same happens in reverse when we subtract 1 from the highest negative value. If you think you might run into the limits, it is simple to check if the value has gone negative or positive, which will detect the overflow. The if statements here and here use this to add an extra space in front of positive values so that everything lines up nicely when using the print function. How you use this behavior in your own apps or games is an entirely different question and will be too much to cover in this tutorial. However, it is useful to be aware of this overflow behavior and that it can be easily detected. We looked at precedence earlier, but let's have some practical examples in Godot. What do you think might happen when evaluating this line of code? As you can see, the result is 48. This is because division takes precedence over addition and we're working with integers, so the result of -5 divided by 6 is 0. The brackets actually force the multiplication to take place first, but they are redundant because multiplication takes precedence over addition anyway. Let's change this a little bit and see what we get. In this case, the result is 7 because the brackets or grouping have the highest priority, so everything in the brackets is evaluated first. Within the brackets, multiplication has precedence over addition, so our bracketed expression evaluates to 48 plus -5, which is 43. Then we divide by 6 and end up with a final value of 7. As with any other interdivision, the fraction is discarded. The takeaway here is that you need to be very aware of how precedence can affect even simple calculations. Using bracketing to control your calculations is useful, but there may be occasions when it is better to break apart a calculation onto multiple lines to both make sure it does what you want and also for code readability. Anyway, so our calculation gives us the result after division. If we also want to know the remainder after the division operator, we can repeat the line of code but use modulo instead of division. As you can see, the result is 1. So that set of examples nicely demonstrated one of the most important aspects of integer maths, where fractional results are discarded by integer division. Godot will give you a warning about losing the remainder each time that you use integer division, but these warnings can be safely ignored when integer maths is what you require. Things get a bit more complicated though when we mix integers and floats in the same expression. As with integers, the floats can be variables or literal values. Here we have a mixture of examples, so let's run the code and see what we get. So we're statically typing our first two variables, x1 and x2, as integers. When we divide one by the other, we get an integer result. However, if we divide x1 by the literal 12.0, we get a different result. This is because 12.0 is a float literal. Adding the 0 to 12 forces this to be stored as a float when the script is compiled. Next, we're assigning the results of a couple of calculations to the variables x3 and x4. We're also using using the := operator to force each variable to use static typing. The first calculation is a pure integer calculation using x1 and x2. The result is an integer, so the new variable x3 is statically typed as an integer. The second calculation uses a float, and as you can see from the result, when we print x4 we get a float. You can easily tell it's a float here because it has a fractional value after the decimal point. So a key point here is that we now have statically typed x4 as a float variable. This is fine if this is what we want, but no good if we want it to be an integer. So what is actually happening here? Well, anytime that a float is validly involved in a calculation, the result will be a float. This applies to multiplication, division, subtraction, addition, and exponentiation. It does not apply to modulo, aka remainder, as modulo only works with integers anyway. If we want pure integer maths or only integer results, all of the elements of the calculation need to be integers when evaluating the final result. This means we sometimes have to go about doing things a different way and force GDScript to do what we want. Let's redo the last example in a couple of different ways. As you can see, the results stored in x3, x4 and x5 are all the same this time. When we're calculating x4, notice the brackets around our float literal and the int keyword. This is called casting, and it is used to force the output of the expression in brackets to be of the required data type. We have just used the literal value in brackets here, but the expression in brackets could be a full mathematical formula using any mixture of integers and floats, but when it gets to this point, the data type is forced to be an integer by the casting. So our final evaluation is an all integer expression and we get an integer result. For x5, we have taken a different approach by predefining the variable to be an integer using static data typing. By the way, if you want to know more about static data typing as contrasted with using variants, please see the tutorial on this topic on my channel. Anyway, we can also apply static typing on one line like this. This means that any value that is assigned to x5 or x6 will be forced to be an integer. In general, this is a safer approach if you're not sure what the result of a given expression will be. This can also help readability of your script when you come back to it after some time. However, it is worth noting that the evaluated result of the calculation on the right of the equal sign is a float. It is then converted to an integer for assignment to the x5 or x6 variable. If what you really want is pure integer maths, you may need to brute force the issue using casting, and this is actually quite common. Here is a simple example. The elapsed time variable is the number of seconds we've been playing some game. This is simulated with the randf range function. The variable is statically typed as a float using the := operator, as the randf range function has a return type of float. To make the division of elapsed time work with the modulo operator, we have to cast it to an int. As you can see, we end up with a whole number. You can also multiply integers with compound data types such as vectors and colour values. That is, you can use multiplication but not any of the other maths operators. When you do this with an integer, the result will be a vector or colour value as appropriate. Here's a simple example with a colour. As you can see, the RGB and alpha values have all been doubled. That's it for part 2. I hope you found this useful, enjoyable and informative. Please like and subscribe so you don't miss future content. In the next and final part of this integer series, we'll be looking at some more things that make use of the 64-bit representation of integers in Godot. Thanks for watching and see you next time.